Hello, friends. Welcome. I'm excited to solve these 20 problems post JAMB, post UTME problems, and these are problems to people take when they want to get into the university. One of the entrance exam, problems, math problems. So I'm excited, and I hope you are as well. If you have not subscribed to this channel, I will encourage you to do so to be one of the first to get notified when I post more helpful content. So feel free to, just scan through the problem, and if you want to, you can just try to solve them. Let's just jump right in. So this the first problem is an integration problem, right? Antiderivative, and we want to find this constant a, right? So we want to use the power rule for the integration, which is integral of x to the power of n dx is equal to, you just add 1 to the power, which is n plus 1 divided by n plus 1 plus the constant of integration, which is k. But for the given problem, this is a definite integral because of the negative a to a, right? So to solve this problem, what I just need to do is just apply the power rule. This is going to be 15x to the power of 2 plus 1, right? Divided by 2 plus 1. Since my limit is from negative a to a, I'm just going to write negative a to a. And from the problem, everything is equal to 3,430, right? Okay, so I'm just going to demarcate this. Now, I can just simplify. So this is just going to be equal to 15x to the power of 3 divided by 3 from negative a to a equals 3,430. And this is just 5x to the power of 3 from negative a to a equals 3,430. And if I plug in a, right, so if you have a definite integral like this, you're going to plug in the upper part first, which is a. So if you plug in a, you have 5a cube minus, then you plug in the lower part, which is negative a, right? So you plug in the lower part, which is 5 negative a cube. Everything is equal to 3,430. So now if you simplify negative a cube is simply negative a times negative a times negative a, right? And this is just going to be negative a cube like this. So I have 5a cube minus 5 negative a cube equals 340. And this negative here, right? This negative here can multiply this negative out here. So if that multiply, I'm going to get this is going to be equal to 5a cube plus 5a cube equals 3,430. And it's just like if you say 5 orange plus 5 orange, that is 10 oranges, right? 5 oranges plus 5 oranges, that is 10 oranges. So 5a cube plus 5a cube is just going to be what? It's going to be 10a cube. This is going to be equal to 3,430, right? And now, because I want to solve for a, I can divide both sides by 10. If I divide both sides by 10, I'm just going to get a cube is going to be what? 343, right? And I can take the cube root. Since I have a cube and I want to find a, I can take the cube root of both sides. If you take the cube root of both sides, that is, you have this. So this is the cube root of 343. So this is just going to give me a is going to be, the cube root of 343 is 7, because 7 times 7 times 7, 7 times 7 is 49, and 49 times 7 is 343. So the cube root of 343 is 7. So the answer here is equal to 7. So that's C. That's C. Oh, okay. This is an interesting problem. Yeah. So now let's look at this second problem. This is a problem on logarithm, right? So if you have a problem like this, one of the first thing you want to do is, I'm going to rewrite my 100 as 10 to the power of 2, and I'm going to rewrite the square root of 10 as 10 to the power of 1 over 2, right? Then I have my negative 1 there, right? To the power of negative 1. So this is just going to be equal to log 10 to the power of 2, 10 to the power of negative 1 over 2, right? Now, there's a rule of logarithm that says that if I have log a to the power of m, b to the power of n, this is the same thing as n over m log a b. So I'm going to use this rule here, right? So this is just going to be negative 1 over 2 divided by 2. So how am I getting that? This negative 1 over 2 is coming from this power here, negative 1 over 2. And then the divided by 2 is coming from this other power here, 2, right? So this is just going to be log 10 base 10. And remember, there's the other rule of logarithm that says that log a base a is equal to 1. So using that rule, this is just going to be, if you simplify what you have here, to simplify this is just going to be negative 1 over 4, right? And then log 10 base 10 is what? Is 1, using that rule. So I have negative 1 over 4, and that's the solution. Okay, that's B, right? That's B. I hope you are following and I hope you're enjoying this. Okay, now let's look at problem number 3. Problem number 3. Okay, so we want to integrate 5x to the power of 5x to the power of 4 plus e to the power of negative x dx. We want to evaluate this integral. So using the power rule, right? I can use the power rule for the first one, the first term, which is 5x to the power of 4. And the power, using the power rule, this is just going to be equal to 5x to the power of 4 plus 1 divided by 4 plus 1, right? And the recall that the integral, so now for the second one, which is the integral of e to the power of negative uh, x, integral of e to the power of negative x dx is just this, is equal to negative e to the power of negative x plus the constant of integration. So using that, I'm going to have plus uh, negative e to the power of negative x plus the constant of integration. So if you simplify this is just going to be 5x to the power of 5 divided by 5 minus e to the power of negative x plus k, right? And if you simplify further, this 5 is going to cancel this 5. You have a x to the power of 5 minus e to the power of negative x plus k. And that's it. So that's A, right? That's A. That's A. Okay, I hope you're enjoying this. So let's look at the next problem, which is this is a composition of function problem, right? Because we want to find h of negative f of x. Okay, now the first thing we want to do is that to make life easy, if you have a problem like this, you want to simplify what is inside the bracket, which is negative f of x. So I know f of x is 1 minus x. So negative f of x is just going to be negative 1 minus x, and this is just x, x minus 1, right? So now h of negative f of x, since I know what h of x is 3 plus 2x, right? So anywhere I see x, I'm going to plug in, negative, the value of negative f of x, which is x minus 1. So I have 3 plus 2. What is negative f of x? Is x minus 1. So I'm going to plug in x minus 1 here. And I'm just going to simplify. So this is going to be 3 plus 2x minus 2. And this is just 1 plus 2x, right? Okay, so what's the option? That's option B. Oh, so let's look at the next problem. So this one, we want to find um, the addition of the y and the x-intercept of the line. Okay, so what can we do here? Now, I want you to note that this is just something to note, that if you have a line, let's say you have a line, a straight line, right? At the at the at this point here where it crosses this is the y-axis and this is the x-axis. At this point here, the value, let's say this point here is a, right? So at this point here, x is 0 and your y is what? Is a. And at this other point here, where it crosses the x-axis, your y is 0. Let's say this place is b, x is b, and y is 0. So basically what I'm just trying to say is that at the y-intercept, x is 0. So I'm going to write at y-intercept, x is equal to 0. So that's the idea I want to use it. So to find my y-intercept, I'll just plug 0 for x in this equation that is given. That's what I'm just going to do. So anywhere I see x, I'm going to plug in 0. So I have 2 over 5, 0 plus 3 over 2 y plus 9 is equal to 0. And so this is just going to be, if you simplify, the first part is obviously 0. 0 times anything is 0. So you have 3 over 2y is equal to negative 9. If you simplify, you have y is equal to negative 9 times 2 over 3. And this is just going to be negative 6, because 3 divided by 9, 9 divided by 3 is 3, 3 times 2 is 6. So this is just going to be negative 6. So now let me find the x-intercept. So now at x-intercept, y is also going to be equal to 0. So at x-intercept, y is equal to 0, right? So what I'm going to do is I'm just going to plug in y equals 0 into that equation, right? So I'm going to have 2 over 5, 2 over 5x plus 3 over 2, 0 plus 9 is equal to 0, right? So if I simplify this, I'm going to get 2 over 5x is equal to negative 9. And if you divide both sides by 2 over 5, because we want to solve for x, you have negative 9 times 5 over 2. And this is just going to be negative 45 over 2. Now, the question says that we should find the addition of y and x-intercept. So my y is negative 6. So I have y plus x. Y is negative 6. And my x is what? Negative 45 over 2. Right? So I can rewrite, because I have a fraction here, right? I have a fraction 45 over 2. Now I want to make the denominator of both terms the same, right? So what I can do to this part here is that I can multiply this part by 1, but I will write it as 2 over 2. 2 over 2 is 1, right? So what I can do here is I can have negative 12 divided by 2 minus 45 divided by 2, right? The reason why I did that is that I want the denominator to be the same, but I don't want to change the problem. So this is just going to be negative 57 divided by 2. And if you do that, if you do negative 57 divided by 2, you are going to get negative 57 divided by 2. So 2 divided by 5, that's negative 2 remainder 1, right? 2 divided by 7, that's 9. Sorry, that's 8. 8, then remainder 1. So this is going to be 28, negative 28.5. Negative 28.5. So let's see. Oh, that solution is not in the option. Probably maybe there's a mistake somewhere. But I'm pretty sure this our working is correct. Okay, let's look at the next problem. The next problem is we want to find the circumference of the circle, right? We want to find the circumference of the circle. So now I want you to note something, that the general equation of the circle centered at the origin is given by x squared plus y squared is equal to r squared. Now note this. This is the equation of a circle centered at the origin. This is the equation of a circle centered at the origin. Now, if you compare this with what I have here, right? If you compare this equation that I have here, so let me just write this under it. If I write this, so this is just going to be x squared plus y squared equals 7 pi squared, right? So if you compare this part, look at this part, just compare this part, right? What is going to be my arrow? My R is just going to be, my R is just going to be what? R is just going to be 7 over pi, right? Now, what is the equation for the circumference of a circle? So I'm going to put C for circumference of a circle is 2 pi R, right? The R there is the radius. So since I know my radius is 7 over pi, so I have 2 pi times 7 over pi, and then I can just divide, right? This pi, we cancel this pi. So this is just going to be equal to what? This is going to be equal to 14. And that's 14 units. So B. B is the solution there. I hope you're enjoying this. Okay, let's move on to the next problem. So this one is similar concept to um, to the previous problem. So in this case, I have this equation, right? What I want to do here is I want to rewrite it to look like, x squared plus y squared equals r squared, right? The equation of a circle, right? So what I can do here is I can divide through by 2, right? Since 2 is a common factor, so I can divide through by 2. So if I divide through by 2, I'm going to get x squared plus y squared minus 25 is equal to 0, because 0 divided by 2 is going to be 0, right? And then I can move the 25 to the other side of the equation. So this is going to be x squared plus y squared equals 25. But because I want to rewrite it in this form, x squared plus y squared equals r squared, right? So I can rewrite my 25 as what? As 5 squared, right? So let me just write the general equation of a circle centered at the origin under. So this is r squared. Now if you compare this part, right? So what's going to be my R? My R is going to be 5, right? My R is going to be 5. So now the question says find the diameter of the circle. Now what's the diameter? The equation for the diameter of the circle. So I'm going to put D. The diameter of the circle is just 2R, is 2 times the radius. So this is just going to be 2 times 5, and this is what? This is 10. I hope this helps. Okay, so that's A, right? Okay, now let's look at number 8, right? Number 8 is still the same idea, but now we want to find the area of the circle. So the first thing, you want to rewrite that equation to look like the general form of the equation of a circle. That's the first thing you want to do. So what I can do is I can divide through by 4, because 4 is the common factor. So if you divide through by 4, you get x squared plus y squared minus 100 is equal to 0. And then I can, take the negative 100 to the other side. So this is going to be x squared plus y squared is equal to 100. But because I want to write it, I want my equation to look like x squared plus y squared equals r squared, right? I want my equation to look like that. So I'm going to rewrite my 100 as something square. And 100 can be written as what? As 10 square. So I have 10 square. Okay. And and from here, if you compare this equation with this equation here, your R is going to be what? Your R is going to be 10. Now, what is the area of the circle? A is equal to pi R squared. So I have pi, and what is my R? My R is 10 squared. So this is 100 pi. So the solution is D. Solution is D. Okay, we're making good progress. Yeah, let's look at number 9. Now we want to resolve this partial fraction, and I'm going to show you a very nice way to do this. Very, very nice. Now, if you have something like this, 1 over 1 minus x squared is the same thing as 1 over 1 minus x 1 plus x using the difference of squares. So the difference of squares says that you have a square minus b square is equal to a minus b, a plus b. So this 1, because I can write this 1 as 1 square, right? 1 square minus x square. So it's going to be 1 minus x, 1 plus x. Now, for if you want to resolve using partial fraction, the way you do it is that you are going to write a over 1 minus x plus b over 1 plus x. So basically what I'm doing is that I'm just writing a over what is in the first part of this denominator, and then b over is what is in the second part of the denominator, right? And now the question is I want to find what is a and what is b, right? So now if you look at this first part, right? If I plug in, if you look at the denominator, if I plug in 1 in the denominator, I'm going to get 0, right? Because I'm going to have 1 minus 1. So if I plug in 1, I'm going to get 0. So what I'm going to do is that I'm going to, that thing that will make this, the denominator of the first part 0, I'm going to plug it into the other part. So if you look at this equation, I have this, right? I'm going to plug 1 into that part. So my A is going to be, I'm going to plug 1 into 1 plus 1. This is going to be 1 over 2. Okay, now I have my A, right? I have my A. So to get my B, now to get my B, which is, I'm looking at this other part, what can I plug into the denominator to make it 0, right? So if you look, consider this denominator here, right? What can I plug in? If I plug in negative 1, I have 1 negative 1 is going to be 0. So if I plug in negative 1, I'm going to get 0. So what I'm going to do is that I'm not going to go into the original equation, right? And I'm going to plug in negative 1 into this part, into this part, right? If I plug in negative 1 into this part, so my B is going to be 1 over 1 negative 1. So this is going to be 1, 2, because 1 negative 1 is 1 plus 1, and that's 2, right? So my A is 1 over 2 and my B is 1 over 2. So so this is just going to be my 1 over 1 minus x squared is going to be, A is 1 over 2, so I have 1 over 2, 1 minus x plus 1 over 2, 1 plus x, and uh that's it. So let's look at what option is that. So that's option C, right? Option C. So this here, that's option C. Okay, and one thing is that you have to be careful with the options because they can look alike, so you have to be very careful. So let's look at number 10. Number 10, okay. Number 10, let's simplify this. Let's simplify this. We want to simplify this. And we are given that sine square theta plus cos square theta is equal to 1, right? Okay, so now look at the denominator here, right? The denominator here is what? Sine square theta, right? So given that sine square theta plus cos square theta is equal to 1, so what I can do is that I can make sine square theta the subject of the formula here. So I have sine square theta is going to be 1 minus cos square theta, right? And this can be written as 1 square minus cos theta square, right? And recall that by difference of squares, a square minus b square is going to be a minus b, a plus b. So using that idea, this is just going to be 1 minus cos theta 1 plus cos theta, right? So my sine square theta is equal to all this, right? So now I'm just going to go into my the given uh, you know, the given fraction. So I have 1 minus cos theta over sine square theta is going to be 1 minus cos theta divided by what I have here. 1 minus cos theta, 1 plus cos theta, right? And and so this part can cancel this part, right? So this is just going to be 1 over 1 plus cos theta, right? So what option is that? That's option A. Okay, we are making good progress. So what I'm going to do is that I'm going to continue in a different video, right? I'm going to continue parts from problem 11 to problem 20 in a different video. Hope this helps. Thank you.